Hi everyone, Mr. Markwick here. In today's video, I'm going to introduce the idea of dummy links when we're looking at critical path analysis. In my previous video, we looked at creating a precedence table and a precedence network to show the steps and the minimum completion time for completing a project which is made up of multiple different tasks. Now, in this precedence table here, we have 4 tasks that are required to complete a project and a precedence network which has been drawn from this precedence table. However, it's drawn incorrectly. To start off with, tasks A and B come from the start node, which is perfectly fine because they have no prerequisites. So they're drawn correctly in terms of coming straight from the start. However, what is incorrect here is that at the completion of task A and B, we have task C and D connecting to both those tasks being completed, suggesting that task C and task D both have the prerequisites A and B, which is not the case. Task D does have the prerequisites A and B. However, task C only requires task A to be complete. All right, so how would we draw this precedence network to show that D requires task A and B to be complete, but task C only needs task A to be complete? That's where we use a dummy link to show this idea. So I'm going to show you how to draw this precedence network correctly. Again, we'll have a starting node, and from that starting node, we link any tasks that have no prerequisites. So in this case, it is task A and task B. Now, task C has a prerequisite of A. So at the finish of task A, we create a node, and that is then the start of task C. But task D requires both task A and B to be complete. So in order to show this correctly, but also show that task A only has one prerequisite, is we're going to draw a dummy link from the completion of task A down to the completion of task B, where I then start task D. Okay, so this dummy link shows that in order to start task D, I need to have completed task A and task B. But in order to start task C, I only need to have completed task A. Again, notice this is this dummy link is indicated by a dashed line or a dashed arc. It's still an arc, so we've got the arrow there. So the arrow is only going from task A to the end of task B, or the beginning of task D. Now, this is actually the completion of the project. So what I'm going to do is I'm going to redraw that arc for task D to join the end of task C, which indicates the completion of this project. All right, let's look at another example. That it was only a project with 4 tasks. So let's look at this one here, a project which has 6 tasks. And how do we draw that precedence network based on this precedence table? Again, we start with a beginning node or a start node. From that start node, we have any tasks that have no prerequisites. Again, it's A and B in this case. So A and B can both come from that starting node. Task C has a prerequisite of A, similar to the example we just looked at. So C can back onto task A. But task D needs A and B to be complete. All right, so this is where we need that dummy link from task A, or the end of task A, to now the end of task B, to show that after task B and task A are completed, I can begin task D. Okay, so I'm just going to put an arrow here to show task D, but it also says that E is also starting at this point here. So E also begins at the completion of task A and B. Okay, so it's a little bit messy now. And task F can only happen after tasks C and D are done. So what I'm going to do is I'm going to converge these arcs C and D, because we need to complete both of those before we can start task E. So let's just converge those here. Okay, and then we've got task F, which can begin once C and D are done. Now, task E and F aren't actually joined at all. They certainly, E is not a prerequisite of F or vice versa, but we need to complete all those tasks in order to finish the project. And they're the last two tasks. So what I'm going to do is I'm actually going to converge those two arcs to the finishing node. So I'm going to get rid of arc F here, and I'm going to draw that down to converge where task E also finishes, and that is the finish or the completion of that project. Now, if I wanted to work out the critical path and the minimum completion time, obviously we would need to put values on those arcs. So let's go ahead and do that for this example. So A takes 3, let's say, minutes, B takes 4 minutes, C takes 8 minutes, D takes 10 minutes, E takes 12 minutes, and F takes 4 minutes. And our dummy link has a weight of 0 because to get to, I guess, this node here, we're only adding the 3 minutes for task A once, okay? So any dummy link has a weight of 0. And then you can obviously work out what's the longest path through from start to finish in order to work out your minimum completion time and also your critical path, and therefore identify those critical tasks as well along the way, which I won't do to keep this video a little bit shorter, but I will just hop over here and have a look at some precedence tables, see if we can find out which one of these precedence tables, if we drew a dummy link, if we drew a precedence network for each of these, which ones would contain a dummy link? So what are we basically looking for with those dummy links, or if there are dummy links? Notice that here, the examples I've already been through, task A appears twice. Once it appears by itself, but then it appears with another task, okay? And that is where the dummy link is. It is going from A there across to D, all right? That's where that dummy link is, the completion of A to the beginning of D, all right? If we look at the second example I went through, again, A appears by itself here once, but then appears again twice with B, and notice that the dummy link shows from the end of task A, again to the start of task D and E. So that's where those, I should draw a dotted line there, dummy links appear, okay? So you can see that A is by itself as a prerequisite, and then it's with another task as a prerequisite. So that's the clue you're looking for if there is a dummy link in that precedence network, okay? Again, it's by itself, and then it's with another task. So which one of those precedence tables have that pattern? A is by itself, B, C, D appear there once, E appears by itself. Therefore, there is no dummy link in this precedence network. So no dummy link. In the one down here, let's have a look. So A and B are prerequisites to task C and D. C is a prerequisite for E, D and E is a prerequisite for F. Now, the only values that appear twice here are AB and AB, but they both appear twice together, okay? And because they both appear twice together, it's fine that C and D both link on to the end of where A and B converge at a node. So there is no dummy link here. Okay, what we're looking for is when a task appears by itself or with another task, and then with another task or a completely different task later in this table. So A, B, B, E, D, F, C. There is no dummy link in this precedence network, again, because although A appears twice, B appears twice, they don't appear multiple times with another task as a prerequisite. If it was B, C here and B here, then there would be a dummy link, okay? But there wasn't, it wasn't. The last one, hey, you guessed it, that's right. Can you see what we're looking for here? You can see that C appears twice, but by itself. A appears twice, and this time A appears once by itself, and then again with another task. So in this case, yes, there would be a dummy link. Okay, so watch out for that pattern to identify if there is going to be a dummy link. And where would the dummy link be coming from and going to? It would be going from the end of task A to the beginning of task E, because E has the prerequisites A and B, but D only has the prerequisite of A. So D can start at the node A finishes, and that's when the dummy link from the end of A needs to go down to also converge with the end of task B and converge with the beginning of task E, if that makes sense, right? So that's basically what you're looking for if there is a dummy link in the precedence network, just from looking at the precedence table. Anyway, hope that helps, and thanks for watching.